All right, so let's do an example where we are charging a capacitor. Let's say I've got a circuit here, and let's say that I have my pulse source right here. I want it to pulse from 0 up to 2 volts. I'll connect a resistor series with another resistor, and then I'll connect my capacitor out here. I'll make this a 1K and this a 2K resistor. Let's just make this a 2.2 microfarad capacitor. And of course, this is VC of T, the voltage across the capacitor that I'm interested in. And then this is going to be my VS, and this is my VC. And I want to know what is VC of, and I'm also going to tell you that since it's charging, let's just say that the initial condition is that VC of T equals 0. So VC of T equals, VC of T equals 0 is going to be 0, which means my capacitor is initially charged to 0 volts. And I want to know what is VC of T equals 10 milliseconds. Okay, that's what we're interested in figuring out here. Okay, what is the voltage across the capacitor at time t equals 10 milliseconds, okay? And so if I know that this is a charging capacitor, I can go right back to this slide and grab my charging capacitor equation, which is this one. Let me grab that. Come right back over here. So this is the expression that we know we're going to be using. Well, we know the final voltage straight from here, right, is going to be 2 volts. So I can just start with 2 volts. 1 minus e to the minus t over RC. Okay, now RC is R times C. Well, previously our R was just this resistance here that's in series with our capacitor. Well, how much resistance do we have in series with our capacitor? Well, we don't only have a 1K, we also have a 2K. So what we need to do is take those two resistors in series. Okay, so what I would put in the RC slot is 3K, right, the two resistors in series, multiplied by my 2.2 microfarad capacitance, and that is going to be my expression for VC of T. All right, and so if I go ahead and solve, I can just solve for tau separately and say that 3 kilo ohms times 2.2 microfarads. My K and my micro cancel to give me a milli. So I'm going to get 3 times 2.2 milliseconds, which is going to be tau is 6.6 milliseconds. Okay. And so let me go ahead and rewrite this expression that VC of T is equal to 2 volts multiplied by 1 minus e to the minus t over tau. And we know tau now is 6.6 milliseconds. Okay, so all I need to do to determine VC of 10 milliseconds is just plug 10 milliseconds into this expression. Okay, so VC of 10 milliseconds is going to be 2 volts multiplied by 1 minus e to the minus 10 milliseconds divided by 6.6 milliseconds. Okay, the millis cancel, so I just get 10 divided by 6.6, and I should get some value for VC. Let me go ahead and grab my calculator because I don't have it out right now. And I want to go ahead and calculate this just to make sure that I don't make any mistakes. Sorry, all right, so let's go I'll start with the negative 10 over 6.6. Negative 10 over 6.6, I want to go e to the power of that. Okay, 1 minus that answer, and I multiply that by 2, and my answer is 1.56 volts, okay? All right, so I just determined the voltage. So if I was going to plot this, what does this look like? Let me go ahead and draw a plot here. I know this is T. I'm interested in VC of T. I know that my capacitor was initially 0 up to time T. And at time T, starts rising exponentially. Of course, at roughly 5 tau, it would be 99% of the way there, right? But we just wanted to find 10 milliseconds, which is somewhere down here. So at 10 milliseconds, we just determined that the voltage, VC, is 1.56 volts, okay? And of course, we know from the problem, let me actually move this up and out of the way. We know from the problem that this is going to asymptote at about 2 volts, okay? So our maximum voltage here is going to be 2 volts, and we discovered that at 10 milliseconds, the voltage is 1.56 volts. So if we wanted to find another value of t, we could easily just plug it right into this expression here for t and solve for other values. So sometime much, much later, let's say 75 to 100 milliseconds, our value should be really close to 2 volts, if not exactly 2 volts. So let me just plug another one in. Let's try 75 milliseconds, just because I said that already. If I take that, and I want to go e to the power of that, 1 minus my answer. Yeah, now I multiply by 2, I get 1.999999 volts. So sometime much later at 75 milliseconds, then my voltage is 1.9999 volts, which is basically 2 volts for all intents and purposes. Okay, so this is our charging a capacitor example. Maybe I'll do another example on the next slide, just to make sure that these concepts are clear. Maybe I'll switch up the circuit a little bit, but hopefully this is clear. If you have any questions, obviously feel free to ask, and I'm going to go ahead and stop the video right here.